Assalamualaikum, my name is Hanif and my number is DD220064. So for abstract, the essay looks into the properties of electroplated mild steel vs graphite, brown vs graphite, and copper nickel vs graphite. The chosen solution for this electroplating experiment is Coca-Cola. A bit interesting. Electroplating is the technique of applying an electrical current to a surface to create a coating of a metallic. In the experiment, graphite was applied to the substrates in the tin adhering coating. It was investigated how process variable affected coating quality. The anode and cathode range must be taken into account for the experiment to be successful. Coca-Cola was employed as the electrolyte solution in the experiment. According to the study's finding, adjusting the anode and the cathode distance might enhance the throwing power for plated through hole and microwave plating and deposition distribution. The discovery helped us understand how electrochemical deposition works and can be used to improve surface qualities.
Assalamualaikum and hi, my name is Muhammad Arif Berani. My matrix number is DD20039. So today I'm going to present about introduction and methodology of electroplating experiment. So electroplating is a process of producing a coating, usually metallic, on the surface by action of electric current. It also a process of transferring metal ion through a solution from a positive electrode to negative electrode with the help of electric current. The main purpose of the process is to prevent corrosion process, increase surface hardness of material, change physical property, and for the decorative purpose. It involves reducing metal cation to create a lean metal coating on the electrode. Continue. This experiment was conducted to investigate the effect of various concentration of medium on the mass of different metal at the cathode from 10 to the 15 minutes. The objective of this experiment is to identify how the different concentration of the medium affect the initial and the final weight of metal, especially for mild steel, bronze, and copper nickel. So we continue to the methodology of electroplating experiment. So for the methodology, I will explain three components, which is equipment, procedure, and setup. So for the equipment of this experiment, the first item is a 100 milliliter brick breaker, graphite rod, set of elongated clip, emitter, 12-volt battery of other power source, and retort stand, bronze, copper nickel, and mild steel. For the electrode, we use Coca-Cola as our electrode for this experiment. So we go to the experiment setup. The first is preparing the sample, electrode preparation, setting up the electroplating apparatus. Next is electroplating process, and the first step is post-plating step, and the final is analysis and evaluation. So for the procedure, the first step is we grading the mild steel, then we polish the mild steel and set up for the apparatus. Then we wake the mild steel, place the beaker, and clip the graphite rod and mild steel. We switch on the power supply, then remove the mild steel and rinse it with the diorganized water. And eighth step, we weigh the mild steel and record it. Repeat this step using other mild steel and run it for 30 minutes. Next step, for the last step, we repeat the step by using the other method. That's all from me. I pass to the next presenter. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif Hakim bin Muhammad Zainuddin. Matrix number DD220049. So today I will explain about the result and calculation. So the first table is the result of electroplating for 4 cm distance. So we get this for the 3 sample, which is mild steel, bronze, and copper nickel. So for the table 2, also electroplating result, but we reduce the distance, which is 2 cm. So for the calculation, we calculate the percentage change of sample for 2 cm distance and 4 cm distance. So after calculate it, we got this is the percentage change of sample for 4 cm distance after 10 minutes and after 30 minutes. So the formula we use, WF minus W naught per W naught multiply by 100%, and we get the percentage of mild steel, bronze and copper nickel. After we calculate it, we see the difference between sample of 4 cm distance and 2 cm distance. That's all from me. Thank you.
The observation for this experiment, we use the distance of 4 cm and 2 cm for electroplating setup. In electroplating, the distance between the electrolyte can affect the plating process and resulting cutting. Okay, the electrode deposition rate, the distance between the electrode can affect the rate at which metal ions are deposited onto the electrode. A distance of 4 cm is greater than a distance of 2 cm, resulting in slower rate of deposition compared to a shorter distance based on the experiment conducted. For coating quality, the distance between the electrode can affect the uniformity and adherence of the coated coating on electrode. A larger spacing may lead to less uniform coating on potentially problem with an iron than the 2 cm spacing. The current flow for this experiment for electroplating setup, the distance between the electrode affects the electrical resistance of the electrolyte. The distance 4 cm greater than 2 cm may result in higher resistance, positionally affecting the overall current flow during electroplating. This observation may help evaluate the process progress, identify issues, and maintain desired plating coating quality on the electrode. Monitoring change in color, clarity, and composite can help identify proportionally issue and ensure consistent result. For question A, what material should be plating path be consisted of and one? For steel and graphite electrode with cooked water as electrolyte, a suitable copper or nickel solution is required. The charge depends on the desired plating method, such as copper or nickel. Cooked water can improve conductivity and extend the plating process. For bronze and graphite electrode, a bronze plating solution should contain suitable copper and tin salt, such as copper sulfide and stainless chloride. Copper water can also improve conductivity and efficiency. For copper nickel and graphite electrode and copper nickel plating solution should also contain suitable copper and nickel salts, such as copper sulfide and nickel sulfide. Next question B, what ions are present in electrolyte? Okay, steel and graphite electrode with a cooked water as an electrolyte may contain hydrogen ion, carbonate ions, sulfide ions, and other ions due to impurity or contaminant. Okay, bronze and graphite electrode may have copper ion, tin ion, and hydrogen ion derived for the dissociation of water molecule in the electrolyte. Cooked water contains dissolved carbon dioxide, carbonate ion, and sulfide ion. If dissolved sulfide compound are present, copper nickel and graphite electrode may use copper ion, nickel ion, hydrogen ion, carbonate ion, and sulfide ion. The electrolyte composition depends on the source and any relativity impurities. For question C, give all relevant of reaction occurring at the cathode and anode for my steel sample. Okay, at cathode, the reaction of half reaction, we use a H. H means hydrogen. Okay. So 2H plus with 2 electron becomes H2. So the half reaction for cathode is hydrogen gas evolution. In anode, uh, in anode, ferro Fe becomes Fe2 plus 2E. The anode, we can see the ion dissolution in ferro. So might still gains electron and become a solid ion. For question D, third your observation, explain change that occurred to the electrolyte solution during the electroplating process. The electroplating process involves various changes in the electrolyte solution, such as color, clarity, composite, pH, gas evolution, temperature, and electrolyte composition. This change can result from dissolved metal ion, reaction byproduct, and the formation of precipitate or suspended particle. The deposit may be visible on the electrode surface or suspended in the electrolyte solution, while pH change can be caused by reduction reaction or oxidation reaction. Gas evolution can occur due to reduction reaction, while temperature change may occur due to current flow and electrochemical reaction. Electrolyte composition can also change due to metal dissolution, ion migration, or ion depletion. Monitoring this change is crucial to ensure optimal plating condition, maintain desired coating quality, and identify any issue of irregularity. In the last question, for question E, is there final weight difference observed when compared to the different type of sample, and why? Okay, for me is yes. Electroplating process can cause weight difference between sample due to factors such as electroposition, resolution, coating formation, chemical reaction, and contaminant. This difference can result from the deposition of metal ion, resolution of electrode material, coating formation, chemical reaction, and contaminant. Controlling this parameter is crucial to achieve desired coating quality and minimize weight variation. Monitoring weight difference help assess efficiency and effectiveness of the electroplating process, ensuring consistent results.
Hello there, my name is Kenny Alfred with the matrix number of DD220026. Today I will be talking about the discussion part for our report writing regarding the electroplating experiment that has been done in the previous week. Keep in mind that all the analyzed and collected data as well as the observation were taken into account for this explanation. So there are three factors when it comes into the effectiveness of electroplating. So the first one is time, bath water, and electroplate spacing. The first one, which is time, we can all conclude that the longer the experiment taken, the thicker the coating will be. We had two sessions for these experiments, which fall under the collection of data in 10 minutes and after 30 minutes time frame. The method, conducted within 30 minutes resulted in heavier mass when compared, but the method with 10 minutes of immersion showed a more uniform and smoother coating. This proves to us that time regulation is significant when it comes to electroplating. The second one is bath water. We have used two types of electrolyte, which is copper sulfate and Coca-Cola. The recorded data showed that these two electrolytes does achieve electroplating. So it does work with Coca-Cola. However, copper sulfate has proved to provide a much more discerning result as compared to Coca-Cola water bath. Uh, Coca-Cola provided a more contaminated and non-uniform coating result. So the third one is the electroplate spacing between the electrode. We have done two sessions with constant material and electrolyte use. So the spacing is a 2 centimeter and 4 centimeter spacing difference. We found out that the 2 centimeter provided a much thicker coating distribution and heavier mass as compared to the 4 centimeter spacing. However, the 4 centimeter spacing provided a more evenly plated coating in a 30-minute time frame. Therefore, we concluded that the larger gaps facilitate better heat dissipation and reducing the risk when conducting the experiment. So that is all from me. Thank you for listening, and I hope you gain something from this.
Now we move on to the last part, which is conclusion. In conclusion, the electroplating experiment successfully showed how Coca-Cola electrolyte may be dispersed graphite on mild steel, graphite on layer bronze, and graphite on copper. The anode of the experiment is constant, which is graphite, and the cathode is variable, which is consists of bronze, mild steel, and copper nickel. The homogeneous and adherent graphite coating seen on the surface of both substrates provided conclusive proof of the electroplating process efficiency. The analysis of the process variable found that they had a big impact on the electroplated coating quality. Variation in the graphite layers, thickness, and current distance is invisible to acquire desired coating qualities by optimizing these parameters and balancing variables like distance. The result of this study helped explain how my steel, bronze, and copper nickel substrate behave when electroplated with Coca-Cola solution. Wherever improved surface quality, such as corrosion, electrical conductivity, and aesthetic applied, are needed, the information obtained from this study may be put to use. In general, this electroplating experiments offers insightful information on the prospective uses of mild steel, bronze, and copper nickel in electroplating techniques. The discoveries provide up a new opportunities for surface engineering study and development, and also enhance electrochemical deposition methods. Based on the experiment that has been successfully done, what can be shown is that the value of copper is increasing when there is a reaction of graphite and copper nickel, bronze, and also mild steel using the Coca-Cola solution through the electricity. Now, let's talk about the difference in range during the experiment. The value that has been collected is different between all the specimens. The most value increase on coating is mild steel, then followed by the bronze, and finally, the last place is copper nickel. The range that was used in the experiment is 4 cm, which is long range, and 2 cm, which is short range. We can say that when the value of range is decreasing, then the value of coating is increasing. So the range and coating thickness is inversely proportional. The value of the thickness of the coating is variable based on this specimen. Okay, I think that's all from me and my group. Thank you.